So if we start off by asking what the derivative of 3x plus 5 all to the power of 7 is, well, we could expand out all of these brackets and differentiate each term in the polynomial individually, but this would most definitely not be time efficient. So what do? We use the chain rule. And we treat these brackets as just like a variable in itself, and we differentiate like so. But then we have to multiply by the derivative of what's inside of this bracket. So in this case, multiplying by 3. So our final answer would be 21 lots of 3x plus 5 all to the power of 6. So that's just a little reminder on the chain rule. Now, what if we were asked to anti-differentiate 3x plus 5 all to the power of 7 with respect to our variable x? Well, again, we could expand out every single one of these brackets, okay, and anti-differentiate each individual term of the polynomial, but most definitely not time efficient. And in fact, there's actually kind of like a reverse chain rule that we can use, which kind of says, okay, well, let's just integrate this bracket, similar to like how we differentiate the bracket in the differentiation. Let's integrate this bracket as if it were a variable in itself. So let's end up with our 3x plus 5, add 1 to the power, divide by the new power, with our plus c. But now, instead of multiplying by the derivative of what's inside, let's divide by the derivative of what's inside of those brackets. So our final answer here would be 3x plus 5 all to the power of 8 over 24 plus c. So remember, in the chain rule, when we differentiate, we multiply by the derivative of what's inside our brackets. When we use the reverse chain rule and we anti-differentiate, we divide by the derivative of what's inside of these brackets. Let's take a look at maybe one or two more examples. So let's anti-differentiate 5x plus 7 all to the power of 6 with respect to the variable x. So I just integrate these brackets as if it were a variable itself. So add 1 to the power, divide by the new power, multiply or multiply the denominator, which is the same as dividing the overall fraction, by the derivative of what is inside. So I just end up with my 5x plus 7 all to the power of 7 divided by 35, and I can't forget my plus c there as my constant. If we were asked to anti-differentiate 2 lots of 6x plus 1 to the power of 7 with respect to the variable x, well, I could just rewrite this question as 2 multiplied by the antiderivative of 6x plus 1 to the power of 7 with respect to the variable x, okay? So that's just that property, or the scalar property there that we have of integration. So what do we do here? Well, we have our 2 multiplied by our integral. So we get our 6x plus 1. We add 1 to the power, divide by the new power, multiply the denominator by the derivative of what's inside, which is a 6 plus c. So we end up here with just our 6x plus 1 all to the power of 8 divided by 24 plus c. So hopefully that makes some sense on what we call the reverse chain rule. Okay, very similar to the chain rule when we differentiate, but instead we're adding 1 to the power, dividing by the new power, so that's the anti-differentiation, and then dividing by the derivative of what's inside instead of multiplying.